PhD candidate at Guarulhos University. I'm part of a research center for neglected disease. First of all, I would like to thank you for the event and the organization for the invitation and the opportunity to show a little of our work here. Today, I select one of the molecules based on natural products we identify prepared against the schistosoma. So the title of my presentation is Anthelmintic prepared of piplartine in a mouse model of schistosomiasis. So about of the disease, the schistosomiasis is a parasitic and a neglected disease caused by species of schistosoma. The schistosomiasis is called to water belly in the popular medicine relation of main symptom of the the word according to the World Health Organization, more than 200 million people worldwide is affected. In 2017, according to the World Health Organization, about 280 million people need for preventive treatment, but only 74.3 million people receive this treatment for prevention. So the prevention and the control of diseases in the endemic areas, it's very difficult. Here, a list of diseases for the Health Organization. So schistosomiasis. Sorry, have a microphone later. No. Here at the list, have a stack in relation of global prevalence and the population at risk. In this population at risk, in endemic areas, it's very common this scenario, the poor sanitation and the difficulty to encounter a good purity water for consumption. So this situation contributes for maintenance of this disease in the endemic areas. A little about the life cycle of this disease. So have a definitive host of the cycle, the mammals. The host have a of the genome Bionfali. The person infected with schistosoma defecated and eliminated the eggs. These eggs go to the water river and floated in this water, releasing the miracidia. The miracidia penetrated the snail tissues and transform it for sporocysts and then to care. Releasing of the snail and the penetrate the skin of the definitive host. And this penetrate, transform it to a schistosoma, the other phase of the parasite. This schistosoma goes to the blood circulation, mature, and mature to juvenile form of worm. This juvenile form of the worm lives in the hepatical portal system. In the hepatical portal system, this juvenile evoluted for adult worms, and then that adult worms have a sexual dimorphism, the male, and the male pair they go mesoteric Venus in the larva and the eggs. Part of these eggs return with the circulation for the liver and explain and cause a granulomatous reaction, then result for hepatosplenomegaly, and the other part go to the intestine. These eggs mature and were eliminated again to another cycle. The relation of treatment for this disease, treatment based on only one drug, the praziquantel. Praziquantel was approved in 1977, used since 1998, used as single oral dose, 40 to 60 milligrams per kilo, but affect only that form of the worm. And endemic area control of these diseases in this area, praziquantel is used as prevention too. So not only use it for treatment, for the prevention too. This type of prevention, we call it the mass drug treatment. And because of this intensive and the large use of praziquantel appear the tolerance strains, the first registers in animals in 1994, in the humans in 1990. So this situation of the disease and the treatment and the prevention justify the search for new molecules based on natural products, especially because of the biodiversity in Brazil. And based on this, we encountered the Piparaceae family, mainly the plants of the genus Piper have axiolated, vasodilating, anesthetic, analgesic, and anti-inflammatory properties registered. In relation to the molecule encountered in these plants, the piplartine found in several species of piper, especially in roots of a piper tuberculare. Piplartine have a register of different biological properties, mainly anti-cancer, against Leishmania, Trypanosoma, and the Plasmodium, the parasite caused the malaria. And based on this literature, we tested against schistosoma, and we registered two. So first of all, to identify this property, we made a trio with adult worms in vitro assays. For this, we use swift mice infected by subcutaneous injection. Care. First 2 to 49 days post-infection, we made a perfusion and retired these worms. These worms was deposited as couple 12 in 24 well plate with a medium, 10% of EPS, more antibiotics. And for positive control, we use the 2 micromolar praziquantel. So first we made a screening relation of extract and the fractions, and then the pure substances, and tested again for lower concentrations, and then identified the LC50 lethal concentration in 50% of population. So as a result, we identify LC50 as 12.6 micromolar. And we, in addition, we analyze the tegment of this worm treated with piplartine. Here, in these images of confocal microscopy, we identify alterations of the tegment of this parasite. In 2011, and another study we made to identify in another phases of the parasite here in worms. First of all, we infected ciadas. Then to 30 days, we exposed these snails to 3 to 4 hours of light. Then, releasing the circuit, they made a break mechanism to break the circuit and obtained the young worms. Here, we call it the newly transformed schistosomula, or NTS. So around the 15 ETS, we put it for well in 26 well plate with 169 medium, 10% of FPS, more antibiotics. And for control, 20 micromolar of praziquantel. And here, the LC50 we identify 7.5 micromolar. And we analyzed to show the tegment of the parasites, these young parasites, and we identify very severe alterations in different ages of the young hours, days and 7 days. This study was published too in Experimental Parasitology in 2012. And we identified too, we analyzed really the synergism of this molecule with another molecules with schistosomal properties. In here, we analyzing the synergism with piplartine and dermaceptin. We identify this synergism in here, demonstrated in the image D, the alterations of pigment, and have to this synergism to death the worm too, and the young worms too. We identified synergism demonstrating this image with the alterations of the teguments of the young worms. This study was published in Current Medicinal Chemistry in 2013. And another synergism, we analyzed the synergism between piplartine, ipsoplotrine, and praziquantel. We identified too the synergism with this molecule, the piplartine. So here in the confocal laser microscopy, here the piplartine and the praziquantel, piplartine and the ipsoplotrine, and the praziquantel and ipsoplotrine. So have worms, and then here the analysis of scanning electron microscopy will identify this study was published too in the Biomedicine and the Pharmacotherapy in 2017. And we analyzed it too in the in vitro assays. We decided to construct some syntactic analogues to reduce a little of toxicity of the piplartine. We iteration the rings of the piplartine, and we tested in ammonia fibroblast cells and the macrophage biopsy, and we identified but the analogus was inactive against schistosoma. This was published too, International Journal of Molecular Sciences. So for the in vitro assays, we analyzed all the principal possibilities with the synergism and in various phases the parasite. And then now the animal model, of course, we analyzed the effect. For this, first of all, we made a collection isolation in collaboration with Professor Guilherme Dar and the Professor João Lago. These roots was collected in Jardim Botânico do Rio de Janeiro, and the voucher was deposited in the herbarium of Biosciences Institute of USP. About the isolation, these roots were dried and powdered, and the extraction used NXN, and the profile was identified by TLC plate, goes to the chromatographic column, and then the spectroscopy studies to identify the purification of the sample, and we obtained 100% of a pure sample. The methodology in animals, we use is with mice infected around of AIDS care by subcutaneous injection. In the first step, we use 5 groups with 5 animals each one. In here, first, a group control infected but not treated. Group 2 treated with 100 milligrams per kilo at a single dose of piplartine. Group 3, 200 milligrams per kilo at a single dose. Group 4, 400 milligrams per kilo, and group 5, 100 milligrams per kilo daily for 5 consecutive days. In the first step, we tested in patent infection. This patent infection is 42 days post-infection. In here, we have adult form of the worm in the organism of the definitive host, and then we tested in 56 days post-infection. We analyzed the therapeutic efficacy. Then to analyze the better dose in this treatment in the patent infection, we made a new treatment in pre-patent infection with only 3 groups now. Group 1 for control, and one group treated with 400 milligrams per kilo at a single dose, and the other group treated 100 milligrams per kilo daily. And here the pre-patent infection, it is 21 days post-infection. In this phase, we have juvenile worms in the portal system, the hepatic portal system of the definitive host. All the mice was treated by GAVage. For therapeutic efficacy, we analyze 4 topics mainly. The first, the organs affected for the disease, in here the liver and the spleen. We analyze the mass of these organs. We analyze the quantity of eggs in the feces by catocast. Here we retard 1 centimeter of the intestine and analyze the quantity of eggs and classify it as mature, immature, and dead. And we analyze, of course, the worm burden of these mice. We count and dissect it as male, female, and the couple. Relation of the results. Relation of the worm burden in the pre-patent and patent infection. In here, the patent infection for all these different doses, the better dose was 400 milligrams per kilo in the patent infection, reducing around of 60.4% of worm burden. In the pre-patent infection, we identified the better dose was 100 milligrams per kilo for 5 consecutive days. In relation of position in pre-patent and patent infection, again, the relation of egg burden in the feces, again, the same dose was the better. Summing up, compared to praziquantel, the praziquantel is the gold standard drug for treatment of the schistosomiasis. The patent infection, piplartine was the better. Here, praziquantel 9% of the worm burden, and the piplartine only 60.4%. On the other side, the pre-patent infection was better in the compared to praziquantel reducing around 25% of the worm burden. This reducing not as good, not as considered effective, but the piplartine reduced around of 60%. This worm burden, this reduction, but the piplartine not as good in compared to praziquantel, but it's good for the disease because in compare of the protozoal disease, for example, in the protozoal disease we have a replication of the parasite in the definitive hosting. Here in the schistosoma we don't have this replication, so reducing around of this burden, it is good and not as a gold standard, but it's good. We analyzed too the teguments of the worms by SAM. In here, we made it with collaboration with Professor Maria Cecilia Salvatore. We infected 3 mice with we treated it with 400 milligrams per kilo in 24 hours post-treatment. We retarded these adult worms and spread it with gold and analyzed in the cell. Here, about the results. We identified 2 the alterations of tegument, and here mainly the tubercles and the spicules of the schistosoma. In conclusion, the piplartine causes significant reduction in the burden of position, the pre-patent and the patent infection, and they cause morphological alterations on the tegument of the different phases of the parasite. So the piplartine, a bioactive molecule derived from medicinal plants, has the potential to treat schistosomiasis, but we don't know the mechanism of action yet. This study was published in Acta Tropica in this year's January in specific. My knowledge goes to the events. Thank you again for the invitation and the opportunity to Guarulhos University, all the collaborators in here of this work, and the further institutions too. And of course, for Research Center for Neglected Disease, mainly Professor Josué de Moraes. Thank you for the attention.